All right, so go ahead and log into SciFinder, and we're going to continue our discussion on the structure search feature. Uh, if you're coming from the other video, then that's why it looks like this on my screen. But you might log in and click on chemical structure, and it'll just be a blank here, right? So go ahead and get to your chemical structure search, click on it here, and there should be a blank screen. So in this video, what we're going to do is figure out how to synthesize a molecule. Okay, so we're going to look for our classic ionic liquid, the BMIM TF2N, um, and we're going to draw that in, right? And we're going to look for to see how we could synthesize this stuff. So first of all, we need to draw our structure, okay? So down here at the bottom, here we have some of the classic ring archetypes, I guess, or moieties, whatever you want to call them. So we need our cyclopentadiene here. Now, with these ring systems, what you can do is you can click and hold, and you can rotate the rings around to make it a little bit more reasonable, I guess, depending on how you're comfortable with drawing these things. Remember, it doesn't really matter, right? But I'm just more comfortable drawing the BMIM part when it starts to look like this. So down here at the bottom, click, hold, and drag. You can rotate this stuff. Okay. Now, here at the bottom, we have our heteroatoms. So you can click on nitrogen. So we can nitrogen, right? Good. Now we need to add our alkyl chains to the nitrogens. So if we click on the carbon, and then we go up here to click on the nitrogen, it's going to turn the nitrogen back into a carbon. So what we need to do instead is click, hold, and drag, and then we can add our methyl group. So click, hold, and drag. We add our methyl group to both sides. And then we can just mouse over and click, click, and click. Okay? So there is our butyl methyl imidazolium, right, the BMIM part. It needs a positive charge right here in green. Click on the nitrogen that's going to have a positive charge on it, right? So we're looking for the nitrogen with 4 bonds to it. Fantastic. There is the BMIM part. Let's take care of the TF2N. So I'm going to start with a nitrogen in the middle. I'm going to build up the structure. Remember, click, hold, and drag. I'm going to draw the basic skeleton here. Then I'll come back and talk to you guys. Whoops. Oh my goodness, I'm missing, right? There's that. Yeah, there's that. Okay, we don't need to win an artist award here. I'm going to add my sulfurs next to the nitrogen there. That's where they are. These guys are going to be oxygens. We click there, and there's our buddy oxygen. Good. Okay, now the sulfur oxygen should have a double bond. You can go down here and click on the double bond and click in between there, or you can just click in between here and it'll turn them into double bonds. So either way. So click, it'll turn into a double bond. If you click again, it'll get rid of it. You can even make triple bonds if you keep clicking, right? So click in between two things to increment or increment the bond count in between there. Okay. Cool. Now at the end of these chains, you should have a CF3 group. So we could put 3 bonds to fluorine on there. Okay, we could do it like this, and that would be fine. Although that takes a lot of clicks, and I'm lazy. So what we can do instead is this. All right, so back to here. If you go down here to the bottom, there's a little typing window. So you click on there, and you can type CF3, and then just boom, click and click. Whoops, goodness. Click and click. Okay. Now, there are certain abbreviations for functional groups or structural features that are common. Like a nitro group, you could just type in NO2, and the system will know that you're trying to type in a nitro group. Like CF3 is a common enough group that it has an abbreviation that the system recognizes. So if you know those abbreviations, you can just go ahead and type them in there, right? Oops, we'll come back to that. We'll come back to that in a different video. Now, we just need to finish this up by giving this a minus charge. Perfect. There is our BMIM and our TF2N portion. Okay? So if you want to pause it, catch up with the drawing, whatever you need to do, we'll give you guys a second here. All right. So we're going to do the exact search. So we'll hit OK. It's going to say, hey, this has multiple fragments. Yep. Hey, this exceeds the standard valency. Yes, it does. Right? So just click through that. That's fine. Okay. And then we hit search. And, all right. So it says we have 31 substances. Now, as you go through, you'll see that these are not exactly what we want, right? We want this here, but then it's got this thiocyanate in there also, and this is the deuterated version, all this kind of stuff. So if you're doing a search and we can't find exactly what we want, it's usually just a way that this system has sorted our answers. So what you do is you go up here to the sort by, click on this, and go to number of references. Now what's going to happen is it's going to sort it by, it's going to find the substance that has the most references. Usually that's what we want, right? Usually we want the one that's already been made before, especially if we're trying to repeat a synthesis, right? If not, then you just have to kind of go through and find it. But in this case, this is what we want. It has a mere 4,500 citations. This right here is commercial sources, right? So we could even check out who sells this, right? And could order it from them, right? So sort by number of references is usually the way to go. So all right, so now we finally found what we want. Let's see if we can dig into this a little bit here, right? So as we mouse over, because we have two components in our substance, we have to be careful, right? So if I mouse over this, only the anion part gets selected. If I mouse over this, only the cation gets selected. As I move to the outside, then the entire thing gets selected, which is what we want, right? So you mouse over the outside part, click here, there's our Cas number, and we want to synthesize this. Okay? So it's going to pop over here. It says, okay, I found 242 different reactions. That's good. If you have a lot of reactions like this, something you can do is you go to the group by and go to document. Normally what SciFinder does is it breaks apart all the individual parts of the reaction in a document, but this will kind of trim down on it and put it all into one. Again, you don't have to do this. It just makes it a little bit easier if there's a lot of stuff to scroll through. Okay, so what do I normally do at this point? Well, once I am looking for how to make something, I just kind of scroll through and see what everybody else has done. So as you can see, there's a numbering here, right? 1 and 2 and all the way up to 242, right? There'll be 242 different references for how to make this stuff. Now, we're not going to go through and look at all those because that'd be ridiculous. But what we will do is we'll start to take a look at some of the individual parts. So taking a look at the top here, right? They mix the lithium salt of the TF2N plus the chloride salt of the BMIM to make the final compound in 59% yield. That's honestly a very low yield for this. I'm not sure what's going on with that, but usually this is, almost 100%. But hey, it's all good. We have everyone has, bad days in the lab. But anyway, so how do they do this? Well, here we go to steps and stages. So this is a one step, right? That's what the 1.1 here means, right? This is a single step. H2O, that means the solvent that they used is water. RT is room temperature, and they did this for 18 hours. So to translate this, what they said is they mix these two things together in water at room temperature, and they stirred it overnight. So they came in, they let this stir overnight, and then they made this compound. Okay. Over here is the reference for this, right? This is from PCCP, Physical Chemistry, Chemical Physics, an excellent journal. So I'm sure this is a really, really good article, right? High quality. So this would be a good one for me to pull, right? Remember, you could click on other sources and go through and pull the actual article itself. I'll do a separate video on how to read an article. So we'll go a little bit more into that later, but there's another video which I already talked about how to pull an article, okay? Okay, so that's good. I keep scrolling down. What else do we see? Okay, the lithium salt, the chloride salt. This doesn't give us any information. That's kind of annoying. Dalton Transactions, though, good paper. Good journal. Here is here's one with multiple steps, right? We have 1.1 and 2.1, right? In the first, they use acetonitrile at 60 degrees Celsius for 3 days. That's absolutely overkill for this first reaction, but that's okay too, right? And then the second step, they used water at room temperature overnight, right? So we're starting to see some patterns emerge. They make the halide salt in the first step, and then they do the second step in water overnight, right? Here they mix these two together in two steps. The first one 7 days at room temperature. My goodness, right? And then solvent in 18 hours, so basically overnight, right? Here's another one. No experimental detail though. Here they used isopropyl alcohol for 24 hours, right? It looks like they mixed this all together. That's kind of interesting. 4 days at room temperature. No experimental detail. 2 days at room temperature with water. Ethanol heated, water. Toluene with then water. Whoa, that's yeah. We'll skip that one. Ethyl acetate for 14 days. Okay, all right. So don't set up a reaction for 14 days. That takes maybe 4 hours at most to do. So anyway, but we'll talk about reading papers a different day. But okay, so here we are, right? So we kind of looked through. We saw the different journals and the different ways of doing this. Okay, so now let's see. I was looking through this before, so let's see if I can find it again. I'm going to go to page, I believe it was page 5. So I think it was page 5. Let's see. I'm looking for a specific reference. If I was a smart man, I would have written it down, right? But what did we learn? I'm not smart. Okay, this is what it was, page 6. Okay, so here is a reference that looks pretty much the same, right? They mix the imidazole plus the chlorobutane, right? So they do the alkylation to make the halide, right? And then they do the metathesis step in water there. So classic example, Macromolecules, a very good journal. And so what you see, what's different here is they've got this blue experimental procedure thing. Now be careful, I'm not talking about this methods now. You see a lot of this methods now stuff, it's a paid service that we really don't have access to. So you get a couple free clicks with it, but after you use the free clicks, you're done, right? But sometimes they have this experimental procedure part here. So if you click on that, it pulls part of the article in to say the narrative of how they made their stuff. So to synthesize the BMIM TFSI, TFSI is just another abbreviation for TF2N. So to synthesize the BMIM TF2N, 1-methylimidazole and N-chlorobutane were combined in a 1 to 1.1 molar ratio in cyclohexane and refluxed for 48 hours. The cyclohexane phase was then removed. The resulting BMIM chloride was dried, and then it gave us our final product, and then it apparently doesn't have the procedure for step number 2. But it tells us about step number 1, how to make the halide salt, right? That's useful. Let's keep scrolling down. Here's another example of an experimental procedure. Okay, so the HMIM, that's a slight typo there. They were talking about a different ionic liquid, but that doesn't matter, right? Was prepared by mixing equal molar volumes of the chloride salt and the lithium TF2N. The ionic liquid phase was separated and washed 5 times with water. The yield is almost quantitative. And then they were talking about the other stuff that they do, right? So there's a little bit of narrative in here. JChem Engineering is a fantastic journal too. Let's see. Here's some more experimental procedures. Let's see what they did. Oh no, that we don't care about that one. Let's see what they did here, right? Combined, resulting. Boom, boom, boom. Okay, so whenever you see these experimental procedures part here, those would be good to kind of click on. It'll give you a little bit narrative of a narrative of what's going on with it, right? So if you find those, what I usually do is copy and paste this into a text file, and make sure to copy and paste the reference also so you can easily find this again. Okay? So if you're trying to synthesize something, this is the way it's done. You do a structure search, right? I'm scrolling up to the top, right? You do a structure search. You sort your substances, right? You sort by number of references, and then you click and you click here and go to synthesize this. Okay? All right, that's it for this video. Hopefully this will be helpful for you guys as you're trying to find some new compounds to make in the lab.